So we had said that we need a greenhouse effect on Earth in order to maintain this thermal balance. That we've got the Earth, we've got radiation coming to us from the sun, Earth's radiating energy back into space. Now, if Earth is radiating energy back into space at exactly the rate we're getting it from the sun, or with perfect efficiency, then Earth would actually cool down and would be an average temperature of a few degrees below 0 Fahrenheit. But we do not emit with perfect efficiency. We hold on to a little bit of that heat, so it's less efficient at emitting light. This efficiency reduction is the greenhouse effect. We still radiate at the same energy we're getting from the sun, and that's maintaining a balance. But this balance has been shifting over time. That's the reason for this. This efficiency shift over time is that carbon dioxide has been removed from the atmosphere at just the right rate that it maintains the right balance. Now, there have been times in the history of the Earth that this has gotten slightly out of sync. For example, major volcanic eruptions release extra CO2 in the atmosphere, and so we had additional greenhouse gases. Giant bursts of plants took more CO2 out of the atmosphere. So this has actually shifted back and forth a bit over the history of the planet. And so this has led in part to various warmings and coolings. The other thing that governs these warmings and coolings are the Milankovitch cycle that we talked about earlier when we talked about the orbit of the Earth and how that also can affect things and affect ice ages and so forth. So there's a variety of things that happen. The other thing that can affect the warming and cooling in the Earth would be the continental drift, the plate tectonics, moving the continents around. That changes the ocean flow patterns, the currents in the oceans. That changes the weather patterns, the climate patterns, where it rains, where it doesn't rain, deserts and forests and so forth, where that changes the albedo of the planet. More heat being absorbed, less heat being absorbed, more reflected. I mean, all these factors are happening all the time, slowly changing this balance, and that this has over time had slow changes in Earth's climate over geological timescales. Okay. However, that doesn't mean that humans have no impact. We know that life forms do impact the planet. The biosphere and the atmosphere and the climate all interact with each other. We talked about that earlier. And your book points out that we've been producing more carbon dioxide into the atmosphere in recent years than has been taken out of the atmosphere. So the concentration has been increasing. Now, this is a graphic here that also shows that for the early part of the 20th century, all the way back into the 1600s, the dark color line is average temperature of the Earth, which has been gradually increasing, just ever so slightly. But the red, the other line here is solar activity. And so one thing that happens is the sun goes through cycles of activity. When it's more active, then it's produces a little bit more energy. When it's less active, produces a little bit less energy. And so that also drives climate. When the sun's more active, Earth warms up. When the sun's less active, Earth cools down. And you see there's a pattern here that shows this correlation that the sun is actually producing more energy and the Earth is warming. Now, we can run this backwards and find out the sun was much more active and less active at different times. It was very less active here or back several hundred years ago, period of time we call the Little Ice Age, in which it was particularly cold in Europe, and glaciers advanced, and you get cold fronts with freezes in the summertime sometime. But it was also, the sun was more active and it was warmer about 1,000 years ago. Almost. And so during this period of time, you had the Vikings crossing the North Atlantic in small open boats. And That's not just because of big tough guys, but because the weather was really nice. In fact, in Europe at this time, in England, a lot of people lived in thatched roof buildings because it was very warm and pleasant. And so it changed things. This all period of time, being warm and pleasant, you also had tropical diseases ravaging through Europe, the plagues and things of this sort. Were running through Europe particularly powerfully this time when it was warmer and the diseases were more easily transmitted. Okay, so this is natural climate change, but if we extend these graphs that we were looking at earlier, we see, for example, that the sun was getting more active, but starting late in the 20th century, it started becoming less active. In fact, there's another solar cycle that's not plotted. This is probably from your book. Another solar cycle not plotted, the 24th cycle, which is about like that, which is much smaller than these others. In fact, it's the smallest that it's been in well over a century. And it looks like the current solar cycle we're going into is going to be a similar, very tiny one. Okay, what this should mean is that because there's this correlation that the sun becoming more active would mean that the temperature of the earth would be becoming more warm. So that happened, okay, early part of the 20th century. But now the sun's becoming less active, and so as it becomes less active, the temperature of the earth, and that's what's plotted here at the top, should be dropping. Well, it's not dropping, it's still increasing. Okay, what's going on? Well, something else is affecting the climate. And that something else is we have a dramatic increase in greenhouse gases right here. And so this dramatic increase in greenhouse gases, it means that that's overwhelming the natural effect due to the sun down here. Okay. And so, in fact, we had like a record solar minimum this last cycle, and rather than having a decrease in temperature, the best we can say is that the temperature curve kind of flattened out somewhat and did not increase faster than it had been, and so or slowed the rate of increase. So that's suggestive that we're having an impact here. Now, this means, though, that global warming, the layman's term for all of this, is really a whole lot more complicated than it's generally made out to be. Politicians talk about global warming, business people talk about global warming, laymen that have never taken a science class talk about global warming. Most of them have no clue what they're talking about. And on either side, they have no clue what they're talking about. Because this is a substantially more complicated topic than is often made out to be. And it means that we have more than one thing that's causing this global climate change or global warming. Some of these things may be man-made. Some of the things may be natural. And probably no may in there. Some of these things are man-made. Some of these things are natural. The big question there then becomes not so much, not so much, is it human influence or is it natural, but it's both, and how much do we have to separate out? And the data seems to indicate that humans have had an impact for a very long time, but the human impact has overwhelmed the natural impact in recent decades. And so that means we are having an impact here. Now, exactly what that impact is going to be, exactly how it's going to play out, that's complicated. And we don't really fully understand that part. So it's almost certain that we're going to have an impact, that we are having an impact, but exactly what that impact is going to be is a little bit more complicated. And I will point out, even among scientists, there's disagreement here among the exact impact this is going to be. I think most will agree there is going to be an impact. It's just how much of an impact, how big of an impact, how soon of an impact is it going to be. And clearly humans are having an impact, and it's a negative impact. And so we really want to minimize that if possible. Problem is, minimizing it is not as easy as simply switching to other power generation things. You know, one of the big things here that people talk about is quit producing greenhouse gases. But the problem with quit producing greenhouse gases is we still need to do things. We need energy. And so there are other sources of energy. For example, there's wind energy, solar energy, nuclear energy, and so forth. They all have problems. Wind energy is not the panacea here of great things. Wind energy has its own environmental issues. Among them, there's conservation of energy. When you take energy out of the wind to make electricity, you have less wind. Less wind has a climatological effect. West Texas has some of the biggest wind farms in the country, and they are now realizing there is a downwind effect on the weather there. That downwind effect on the weather is then producing longer range climatological effects. So wind energy is not the solution entirely. It does not produce greenhouse gases, but it does change the atmosphere. Likewise, photovoltaics or solar power, things of that sort, that's again not the pure solution there, because the manufacture of these devices produces massive amounts of heavy metal toxic waste, and then they only have a certain lifetime, and when you're done using them, you now have massive amounts of toxic waste. The material that makes up solar panels is very toxic, and you don't really want to put it into a landfill and have it leach into water. So that's another problem there. And then likewise with nuclear power. It does not produce any greenhouse gases at all, lasts for a very long time, but you have nuclear waste you got to do something with, and that lasts for a long time. And so there is no pure solution here other than perhaps planning better on how you utilize energy. And and probably using multiple, just like global warming is a complicated issue, solving the problem is going to be a complicated issue as well. And there's multiple strategies for doing this, and that's for another class, really.